Welcome, everybody. We are doing 9.02 pre-calculus today. We're on to our second day in the conics unit. We're talking about parabolas, which you guys should have talked about in Algebra 2, so they should be a little bit familiar to you. I'm not sure exactly how you guys did them last year, but we're going to use the formula this year. I'm not sure if you did that or not. So for some of you, it may be new, maybe not. So conics, again, are formed from this double-wrapped cone. We talked last class about the circle, which is a slice parallel to the circular base of the double-wrapped cone. And now we're talking about this one up here. If we took a slice out of that double-wrapped cone to get our parabola. So a parabola is the set of all points equidistant, so the same distance, from a fixed line and a fixed point. That fixed line we call the directrix, and the fixed point we call the focus. Now, if you find the midpoint between the focus and the directrix, that's where your vertex is going to be. And the line that'll pass through your focus and your vertex, that's going to be your axis of symmetry, which we've talked about this year and you've talked about since algebra. So here's a picture of your parabola. You guys know what a parabola looks like. You know what the vertex is. So the somewhat new information that you guys started talking about last year is the focus and the directrix. So things to remember about the focus, it's always going to be inside the parabola. So the parabola is always going to open towards that focus point. The directrix is never going to be in the parabola, and it will never cross the parabola at all. So the directrix is a line, the focus is a single point. The axis of symmetry is perpendicular to the directrix, and it passes through both the focus and the vertex. And the thing that'll be most important is that this distance right here between your vertex and your focus, that's what we're going to call P. So again, it opens towards the focus. And P is the distance between the focus and the vertex. In that case, it's also the distance between the vertex and the directrix, because the vertex is the midpoint between those two. So it's the same distance from the focus as it is directly to the directrix. The hardest part about really the rest of this conic stuff, when we talk about ellipses too, is it's a lot for our brains to kind of wrap our heads around, because there's so much vocab and there's so many things to remember. So I want you to take out and have next to you, as we do these notes, this reference sheet that you guys picked up that last day that I saw you. And today we're going to be focused on just the top part, standard equation of a parabola. So there's a bunch of information on this sheet. Your vertex is HK, P is the number of units. It doesn't want to let me write on this. The number of units from the focus or directrix. I don't know why it won't let me write. Oh, here we go. Maybe. No. So if it has a vertical axis, meaning it opens up or down, I was hoping I could write that. No. Opens up or down for vertical is what you maybe want to write here with that first bullet. Then this will be your equation. So the x will be squared, just like we know our normal parabola to be y equals x squared. And then the formulas for directrix and focus are also given to you. Some of you are going to find those extremely helpful and going to use those, while some of you might just figure it out using the graph. The formula, if you have a horizontal axis, meaning here you might want to write that it opens left or right. So like this picture right here, this would have a horizontal axis. So the axis of symmetry is a horizontal line. Again, I gave you the formulas for directrix and focus. And this is something you guys would be able to figure out on your own. But if the vertex is at the origin 0, 0, so if you subbed in 0 in for H and 0 in for K, these would be the two equations you would get. If P is less than 0, right here, I would write it's going to open left or down. And if P is greater than 0, it's either going to open up or it's going to open to the right. So P is greater than 0, opens right or up. P is less than 0, left or down. Okay. For the next 4 problems, I gave you guys a focus and a directrix. And what I'd like you to do is draw a parabola. So pretty much we're saying, okay, well, here's our focus, here's our directrix. Let's find the midpoint between them. So if I were to draw a perpendicular line here, and that's the midpoint, that's going to be my vertex. So how's it going to open? Well, it always has to open towards the focus. And every point on the curve, so if I take this point right here, it has to be the same distance from the focus as it is from the directrix. If I take this point right here, it has to be the same distance from the focus as it is from the directrix. And that's what creates your parabola. So it helps sometimes with doing these if you really understand what's going on. So knowing and understanding that the vertex is the midpoint between the focus and the directrix, and that every point on this curve must be the same distance from the focus as it is from that line. Okay, so here, if I find the midpoint between the two, that's going to be my vertex. The focus is always going to be inside of the curve, so I know it's going to go something like this. Again, any point I choose, the distance to the focus has to be the same distance to the directrix. Clearly, mine's not drawn to scale, but that's the idea. Okay, so maybe pause the video, draw in your sketches for 3 and 4. Okay, so you guys should have something like this. So this one should be opening to the right, and this one, find your midpoint between those two, and this one should be opening to the left. Again, notice your directrix is never touching or intersecting with your parabola, and the focus is always inside of the parabola. So again, keep that sheet right out next to you as we do these problems. And let's just write out what those formulas are so we have them right here as well. So we've got x minus h quantity squared equals 4p times y minus k. So here's your x squared, which means it's going to either open up, like we've always known y equals x squared, or down. So that means it has a vertical axis. If it opens left or right, then that means the y is going to be squared. So it's going to have a horizontal axis. And our formula is going to be y minus k. So the k always goes with the y squared equals 4p times x minus h. And something to remember again, that p is the distance from the vertex to your focus. Number 1, find the standard form of the equation of the parabola with a vertex at -2, 0 and focus at -3, 0. So I gave you grids on all these just because I think that it helps a little bit to sketch it out and see what's going on. So the vertex is -2, 0. I'm going to label that V, and the focus is -3, 0. Make that green. So I know that my graph is always going to go towards the focus. So, and I know that the vertex and the focus are always on the same line. That line is the axis of symmetry. So I know I'm going to open to the left, towards the focus. Since I'm opening towards the left, that means, like I said, my axis of symmetry is a horizontal line. So I'm thinking horizontal axis. Or I might just be thinking, well, I know that y equals x squared opens up, and y equals negative x squared opens down. So if I open left or right, that must mean that not x is squared, but y must be squared. So that's how I know I'm going to use the second formula. So what do I know so far? Well, I know that my vertex is h and k. So I know y minus 0 quantity squared equals 4p times x minus negative 2, which is x plus 2. So the only thing I really need for this is I need p. So we know p is the distance from the vertex to the focus. So if I go to my graph, I can find that right here. How many boxes did I go? I went 1 box. So that means p is going to be 1. Now, did I go 1 box to the left or 1 box to the right? From the vertex to the focus, I went 1 box to the left. So that tells me it's going to be -1 because you're going in the negative direction. So now I have everything I need. So I'm going to do y minus 0. Well, that's just y. So y squared equals 4 times -1, which is -4 times x plus 2. So all we need is our h, our k, and a p-value. Number 2, find the standard form of the equation with a vertex at the origin. So I'm going to plot that, call it v, and a focus at 0, -3/2. So -1/2, or -1.5. So I'm going to go down a box and a half, and that's going to be my focus. So again, your curve is always going towards your focus. So that means it's going to open down. Vertex and focus always on the same line. That line is your axis of symmetry. So we have a vertical axis of symmetry. Or think to yourself, I know the graph opens down. Whenever it opens up or down, x is squared. So I'm going to use my vertical axis formula, which is x minus h squared equals 4p times y minus k. I know the vertex is at the origin, so I know that my h and my k are going to be 0, 0. So all I need to still do is find, so vertex is 0, 0, which is my h and my k. I still need p. Again, p is the distance from your vertex to your focus. So from my graph, I was at 0, 0, and my focus is at 0, -3/2. So I went down 1.5 boxes. So my p-value is, and since I went down, would be -3/2. So now I'm just going to substitute in. So I've got x minus 0 squared equals 4 times -3/2 y minus 0. So now I have x squared equals, multiply these, gives me -6. Y minus 0 is y. And for standard form, I know we're used to solving for y, but for these, your standard form, based off our textbook too, has the x squared or the y squared alone. So we're going to stop there for our standard form. Number 3. Find the standard form of the equation of the parabola with vertex 1, 0, focus 2, 0. Sorry. So vertex is over 1, 0. Focus is over 2, 0. Draw your curve. Again, we know the focus is always inside the curve. They're always on the same axis of symmetry. So I'm going to open to the right. If I open to the left or the right, then I know that y is squared. So y minus k quantity squared equals 4p times x minus h. Good news, I've already got my vertex, which I know is my h and my k. All I need is my p-value. Okay, so take a minute, pause the video, find your p, substitute it in, and write your equation in standard form. Okay, so we've got y minus 0 is just going to be y squared. This time our p-value, our distance from the vertex to the focus, we're going to the right, so we're going to say p is a positive 1. 4 times 1 is 4, and then x minus 1. And that's your standard form. Number 4, find the vertex, focus, and directrix of the given parabola. So we are given this equation. Now I want to get this into standard form. So let's rewrite in standard form. So standard form again has that x squared term by itself. So we want to get this right there. There we go. All by itself. So to do that, I want to subtract this whole thing over to the other side. All right, now we're in standard form. So our standard form says x minus h squared, quantity squared, equals 4p times y minus k. So I'm writing it underneath so you can kind of see how they compare and what matches up. So looking at this, we should be able to right away tell what our vertex is. So our vertex, you always take the number with the x, take the opposite sign, so that's -1. And the number with the y, +3, take the opposite sign, is -3. So that gives us our h and our k. That is your vertex. Done with the first part. Next part, it says find the focus. So far we have -1, -3. This helps to sketch this out. Is our vertex. And to find our p-value, we're going to look right here. So those match up. So I'm going to set -8 equal to 4p. Divide by 4, p equals -2. Well, p is the distance from the vertex to your focus. We know that x is squared. So if x is squared, it's going to either open up or down. Since it's a negative over here, that tells me that p is negative, which tells us it's going to open down. Or you might say, okay, the p is -2, so I count down from the vertex 2 boxes is my focus. So I know I'm going to have a curve going downward. So find the coordinates of your focus. So that is going to be -1, -5. Now, if you go back to your sheet over here, I have a formula for you. So this is x is squared. So we're on this first one, and I gave you these two formulas for your focus and your directrix. So feel free to use those as well. So the focus is, oh my goodness. Is h, comma k plus p. So if I took h was -1, matches, k was -3 plus p, which is -2, and we get the same thing, -1, -5. So now I have the vertex, I have the focus, and lastly, it asks us to find the directrix. So again, you can figure that out from your graph or use the formula. For the directrix is the same distance from the vertex as the focus is. So if this is 2 boxes away, I'm going to count 2 away. And my directrix is always kind of like parallel to that base of if I drew a tangent line through the vertex, it would be parallel to your directrix. So it never is going to cross that parabola. So I can look at that graph and I know that that is the equation y equals -1. Now, if you didn't know that, then you might use the formula. The formula for the directrix is y equals k minus p. So I would take my k value, which is -3, subtract p, which is -2, so that's +2, which gives me y equals -1. And that is it. Focus, directrix, done. Number 5, find the focus of the parabola given by the equation. So before we can find the focus, we want to get it into that standard form. So we're going to put into standard form, and we're going to do that by completing the square. Now, since I have an x squared, I'm going to do it for the x's. So with parabolas, you're not going to, so last class we talked about circles, have an x squared and a y squared. With parabolas, you're going to only have either an x squared or a y squared, not both. So that's how we can tell it's a parabola. We also know that since there's an x squared, it's going to either open up or down. But since there's a negative out in the front, we know that it's going to open down. All right, so number 1, get all your x terms on one side. Okay, so anything that doesn't have an x is not going to stay. So -1/2 x squared minus x equals y, and I'm going to subtract the 1/2 over to the other side because it doesn't have a variable at all. Number 2, get your coefficient of x squared to be a 1. When we complete the square, remember you can only complete the square if you have a coefficient of 1. So I need to multiply this entire equation by -2, the reciprocal of the coefficient of x squared. I wrote it too many times. So I'm multiplying -2 times -1/2 x squared minus x equals y minus 1/2. And this will be great because it's going to also get rid of that other fraction. So -2 times -x is going to give me positive 2x equals -2y and then plus 1. All right, number 3, we're going to add our b over 2 quantity squared to both sides. Okay, so I need to find, I'm going to use my new b, not my old b. You guys aren't newbies at this anymore. So we take the b value, which is 2 over 2 quantity squared, gives me 1 squared, which is 1. So I'm going to take x squared plus 2x plus 1 equals -2y plus 1, and add my 1 on that side too. So these blanks are the two things, the two 1s that I added to each side. Now I want to take the left-hand side, write it as a perfect squared binomial. So what multiplies to 1 and adds to 2? That's going to be x plus 1 quantity squared, or remember it's whatever it was before you squared it, so plus 1. -2y, combine my like terms, plus 2. And then this part, let's call this step 4, we'll go up here, is the part that tricks a lot of students, is that you need to get the coefficient of y, or if the x and y's have been switched, then the x, that you have to get that to be a 1. So you're not factoring out a GCF over here. And that's important to remember because in this case it is a GCF, but it won't always be. So we're going to take x plus 1 quantity squared, and we're going to factor out that -2, which will leave us with positive y minus 1. And that will be our equation. But it asked us to find the focus. So what you could do at this point is you could just use your formula, which is h and then k plus p. We still need to find our p value though. So we know that our vertex, sorry, I wrote too big here. Our vertex is negative 1, 1. So I got that from the x coordinate is with the x, the y coordinate is with the y. You switch the signs. Negative 1, 1 is my vertex. And this right here, we're going to set equal to 4p. So 4p equals negative 2 divided by 4 gives me negative 1/2. So now I could use my formula, or I could just go say, okay, well, that means I'm going to count down half a box for my focus. So that is good. It matches that it goes down. And find the coordinates of my focus now, which would be negative 1 and then up 1/2. That's my final answer. If you were using your formula, you would have taken your h, which was negative 1, and then k, which was positive 1, plus negative 1/2, so negative 1/2, and that gives us the same answer for the focus. All right, and the last problem here, very similar to the one we just did. Find the focus and directrix of the parabola. This time, though, we have a y squared instead of an x squared. So I would go ahead, pause the video, see if you can do this one on your own, and then I'm going to go through it, and you can check with me. Okay, so again, this is because it's a y squared. We're going to complete the square for y. So I'm going to get all my y's on one side. Everything that doesn't have a y is going to go to the other side. So I'm going to shorten this up. So I'm going to leave my blank right here, thinking ahead. I'm going to subtract over my 8x, subtract over my 25, and leave a blank. Now I notice that I have a 1 in front of my y squared right here. That's good news. So I didn't need to divide by anything to get rid of that or multiply. So now I'm going to do my b over 2 quantity squared. My new b here is 6. It's also my old b because I didn't multiply or divide by anything. I've got 3 squared, which gives me 9. So I'm going to add 9 to both sides. Now I'm going to take the left-hand side, rewrite it as a perfect squared binomial. It's whatever it is before I squared it. So y plus 3 quantity squared equals negative x. Combine our like terms of negative 25 and positive 9 to give me negative 16. There we go. And now we need to factor out whatever's in front of the x to make it a 1 there. So I need to factor out the negative 8. If I divide both of these by negative 8, it'll give me x plus 2. So this tells me a couple of things. I know y is squared, so that tells me it's going to either open left or right. Since it's negative 8, it's going to tell me that it's going to open to the left. I know my vertex, so make sure here it gets a little tricky. You want to make sure you take from the x first. So this would be negative 2, then negative 3, because that goes with the y. It's not always what's written first. That's very important. So that's our vertex, which is our h and our k. And then to find p, we're going to set 4p equal to our negative 8. So p is negative 2. So if I were graphing this, I'd have negative 2, 1, 2, 3. It's my vertex. Like I said, we're going to be going to the left. So I'm going to count to the left 2 boxes is my focus. So I could just take my focus and write the coordinates 1, 2, 3, 4, 1, 2, 3. So it's going to be negative 4, negative 3. Or I could have used the formula h plus p comma k. And then I also asked you guys to find the directrix. The directrix, again, you could use the formulas given to you on your sheet. X equals h minus p. Make sure you know where it is on your sheet if you're going to be using it. Or you could say, well, my vertex was 2 away from my focus, so I'm going to count back 2. And my directrix is never going to cross the parabola. So I see here that it's just going to be x equals 0 once I draw it in. All right, so a little bit of a tricky lesson today. I know it can be challenging, so if you do have questions on anything, please let me know. Next class will also be a little bit tricky, just a lot of different letters and things you have to remember. So make sure you're ready for it. And I hope you are all staying healthy, loving math, and pie out.